In the previous video about double replacement reactions, you were given two compounds that were reactants and you were asked to figure out which ions would trade places and what the formulas would be for the products. We still need to do that, but what we need to do is add one more layer of information. We need to find out if that really would result in a reaction or if we would get what we at Bowie call ion soup, or just a mixture of a bunch of different dissolved ions. Let me show you what that looks like. Here we have a solution of sodium chloride. So it's this compound dissolved in water. The little blue dots represent sodium ions and the gray dots represent chloride ions. This is a silver nitrate solution. So the little green dots represent silver ions and the brown dots represent nitrate ions, and they're all dissolved in water. If we combined those into the same container and we had a double replacement reaction, we would expect the sodium and the nitrate to partner up and the silver and the chloride to partner up. So if we look here, sodium and nitrate would stay dissolved in water. So even though we've written them as a compound, they really didn't go anywhere from where they were before. But here in this little crystal, we see the green silvers and the gray chlorides are stuck together, and in the reaction they have a different state signifier. They don't say aqueous, they say solid. This is that reaction happening, and that white cloudy stuff right there, we call it a precipitate. So these reactions are sometimes called precipitation reactions, and that is the silver chloride. It is insoluble. So it won't dissolve in water, and we can see it. We could actually filter it out with some filter paper. When we see something like this, we would say a reaction did happen. But sometimes reaction does not happen. In this one, we've got some dissolved potassium bromide and we've got some dissolved sodium chloride. So those are my two reactants. Combine them here into the center flask, and notice that they didn't draw any cloudiness in there, and what they zoomed in on was all those ions are all still dissolved. So even though they wrote the products as K with Cl and Na with Br, because they're all still aqueous, still dissolved, no reaction occurred. We don't have anything different than what we started with. We have just a mixture. So this is not a reaction. This is what we might call ion soup. So here's those two same reactions, and we're going to see how we could have known that without having the chemicals to work with. First thing we would do is look up this compound, and we always look it up by the anion, nitrate. Here's nitrate. It's in the soluble section. So if this reaction happens in water, and this is a soluble anion, no exceptions, then this compound would stay dissolved in water. So then we look up the next one. Maybe we change ink color for this. If we looked up the AgCl, we're going to look it up by the anion. So here's the Cl. Again, it's in the soluble section, but we come over here and check and we see that silver is one of the exceptions. It's insoluble. So everything in this section would be solid, whereas anything over here not an exception, we would say is aqueous. So here we would put S. That presence of that means that we had a reaction occur. The other reaction was this one right here. Well, wasn't really a reaction. If we look up the product potassium chloride, chloride is insoluble. Potassium is not listed as an exception. So this would be aqueous. Sodium bromide, if we look up the bromide, soluble, and then this is not an exception. So this also would be aqueous. Two aqueuses, no reaction would occur. Here's an example from your packet, example number 1. We go in with two dissolved compounds, and then we want to look up these products and see will a reaction occur. If we look up the first one, we're going to look it up by the anion. So here's sulfate, and we have aluminum. So we look and see, is aluminum an exception? No. This is in the soluble section. Aluminum's not an exception, so this is going to be aqueous. If we look up potassium bromide, we're going to look it up by Br. Potassium's not listed. We're in the soluble section, so this one's going to be aqueous. Aqueous makes aqueous, this no reaction. Here's example number 2. We go in with two things that are dissolved in water, and I'm going to change pen color for this. Let's look up the two products. Potassium nitrate, well here's nitrate. in the soluble section, no exceptions, so anything nitrate is always going to be aqueous. The other product is PbI2, so we look up by the I. I's are also soluble, and we just double check, but we see Pb is listed as an exception. So even though this whole section over here is AQ, because this is an exception, these are going to be solid. We would put an S right here. This would be our precipitate, so yes, a reaction would occur. Down here, if it's insoluble, these would be S's unless it's one of the exceptions. So if you've got an alkali metal, so lithium, sodium, potassium, in that case it would be aqueous. And by the way, this right here is the most commonly used picture of a precipitation reaction. It's actually on the cover of your textbook. So this PbI2 is the yellow stuff that forms in there, and this liquid is not water, it's potassium nitrate dissolved in the water.